All right, so section 8.4, page 591. Section 8.4, 591. We are looking at the determinant of a square matrix. So just like when we were working with inverses, remember we said that you cannot take the inverse of a matrix if it's not square. Same idea with the determinant. You cannot find the determinant of a matrix if it is not square. So when you are talking about a 1 by 1, the determinant of a 1 by 1 is just going to be whatever the number is in that matrix. So if I'm looking for the determinant of this matrix, then it would just be 2. Now, one thing that we want to be careful about here, the notation that they typically use for a matrix is they'll use those brackets around it to indicate a matrix for us. With a determinant, usually they use bars around those same numbers, so it looks almost like absolute value, only we never use absolute value with these matrices. I shouldn't say never, but we hardly ever would run into an absolute value and a matrix at the same time. So by the setting that we're in, we would know they were talking about the determinant instead of an absolute value. So when you see these bars, they will not always say take the determinant. They might start with this matrix and say take the determinant of this matrix with the brackets around it, but if they put the bars around it, that automatically tells me to take the determinant. So the one thing that I want to caution you about is, for some reason, if I'm working with a 1 by 1, let's say that this matrix right here was a -2, a 1 by 1 matrix that was a -2, then when they tell me to find the determinant of that, they're going to put bars around that -2, right? And so don't mistakenly think of that as the absolute value of -2 and write that it's +2. If you're looking for the determinant of -2, it is still -2. Okay. Then if I have a 2 by 2, we looked at those last week. The determinant of a 2 by 2, remember that we're going to multiply the main diagonal and then we're going to subtract the alternate diagonal. So we're going to go through and say 2 times 2 minus 1 times -3. So what would we get for that guy? 7, yes. If you want to find the determinant of a 3 by 3, you can either use minors and cofactors or you can use diagonals. I think most people prefer diagonals. Okay, so then why do we even have to learn the minors and cofactors? The reason for that is when you get to something larger, like a 4 by 4 or a 5 by 5 or something like that, diagonals no longer work. So I need a method that works consistently, and that's minors and cofactors, but diagonals is a shortcut if I have a 3 by 3. Okay, so let's look at minors and cofactors. When you're evaluating by minors and cofactors, the first thing that we need to understand is something called the checkerboard matrix. This is the checkerboard matrix right here. You can see where it gets its name because it starts with plus up here in the first row, first column, and then it alternates in each direction. So it goes, plus, minus, plus, minus, plus, minus, and same thing, plus, minus, plus, minus, plus, minus. And so it's just like the pluses and the minuses are in the same place as the red and the black squares would be on a checkerboard. Now we've drawn this out for a 3 by 3 since that's what we're working with, but you'll notice the ellipsis dots going in all directions showing that it would expand if you had a 10 by 10. You could just keep going with that same pattern. So when I'm evaluating by minors and cofactors, I'm going to choose any row or any column from my matrix. Doesn't matter which one you choose. As a matter of fact, in our example, we're going to use column number 1, and in the textbook for this exact same example, they're going to use row number 1, and we'll see that we get the same answer either way we go. So we could go around the room and choose, maybe some of you use the first row and some use the second row and some use the third row and some use the first column, second column, third column. We could work it out 6 different ways, and we're still going to get the same answer every time. So if we look at expanding this by minors and cofactors using column number 1, I'm going to go through and take 0 times its minor, and we'll talk about what a minor is in a second, 3 times its minor, and 4 times its minor. Once I find those 3 products, what am I supposed to do with them? Well, that's where the checkerboard matrix comes into play. It tells me whether I'm going to add them or subtract them. So I'm going to match this up. Because I was evaluating the first column, I'm going to come to the checkerboard matrix and say in the first column it tells me to add and then subtract and then add. So that's exactly what we're going to do here. We're going to add and then we're going to subtract and then we're going to add. If I had been doing the second column, like if I had been evaluating by the second column, I would have said minus plus minus is what the checkerboard matrix tells me to do. So that would have been subtract 2 times its minor, add a negative 1 times its minor, and then subtract 0 times its minor. So notice that this sign does not tell me whether my product is positive or negative. It just tells me whether to add and subtract. So, I could have plus 4 and end up with a negative value for my minor, and so that whole thing ends up being negative, not positive. It just tells me whether to add or subtract. It does not tell me what the sign of that particular product has to be. So I'm going to go through to find the minor of a matrix. Let's say that I want to find the minor of 0. Right? If I'm looking for the minor of that entry in my matrix, I'm going to eliminate the row and the column that entry is in. So I'm going to eliminate, since it's in row 1, column 1, I'm going to eliminate row 1, I'm going to eliminate column 1, and the numbers that are left are my minor. So negative 1, 2, 0, 1 would be the minor for 0. If I want to find the minor for 3, I'm going to eliminate the row and the column that 3 was in. So it was in row 2, column 1. What's left over is 2, 1, 0, 1. So that's going to be my minor, 2, 1, 0, 1. So for the minor for 4, I'll eliminate the row and the column. And what's left is 2, 1, negative 1, 2. So 2, 1, negative 1, 2. All right, now what do these little bars tell me to do right here? Find the determinant, yes. So I'm going to go through and I'm going to find the determinant of these 2x2s that I got from my minors. All right, so if I go through and I find this determinant, I'm going to have negative 1 minus 0. For this guy, I'm going to have 2 minus 0. And then for this guy, I'm going to have 4 minus a negative 1. So down here, I have negative 1 times 0, which is 0. I have negative 3 times positive 2, which is negative 6. And then I have 4 minus a negative 1, so 4 plus 1. 5 times 4 is 20. And if I combine those, I get 14. And if you notice example 2 in the textbook, they worked it out using row number 1, but they still got the same 14. All right, so let's go back through that one more time just for review. If you're going to evaluate by minors and cofactors, we're going to start by choosing any row or any column. While I'm trying to figure out which row or column to use, it's going to be a little more strategic. I have some ways that I can make my life simpler, right? What would be the strategic choice to make? Which row or column would I want to pick? What would make my life simpler? Yeah, I heard it. The one with the 0. Because look what happened in this guy right here. 0 times anything is going to be 0, right? So it doesn't matter what the minor is or what it ends up being here. It's always going to be 0 in this last piece down here. So if I can choose a row or a column that has a 0 in it, or maybe there's one row or column that has multiple zeros in it, I definitely want to choose that one because I'll save myself some work. Okay, so we chose column number 1, so that meant that we took 0 times its minor, 3 times its minor, and 4 times its minor, because those were the 3 numbers in column 1, right? To know whether to add or subtract them, we compared it to the checkerboard matrix. And in the first column of the checkerboard matrix, it said add and then subtract and then add. To find the minors, we went through and we eliminated the row and the column that the number was in. So for instance, when we were trying to find the minor for 0, we eliminated this row and this column, and whatever was left over was what we wrote for our minors. And then once we had those 3 minors, then they were just 2x2 determinants that we evaluated the same way that we did in section 8.3 and the same way we did higher up on the page. So once I had those values of the 2x2 determinants, then I could combine and get my overall value. So again, I want to remember that if I happen to have any zeros, that whole piece is going to drop out. There is no need for you to write what the minor would be or calculate what the minor would be. because the end answer is going to be 0 for that component. Okay? All right, let's look at how we could do that exact same 3 by 3 matrix, finding the determinant of that by using diagonals instead. So what I'm going to do is I'm going to start with my 3 by 3 matrix, and I'm going to copy the first and second columns on the outside of that matrix. So copy the first and second columns on the outside of that matrix. When we do a 2 by 2 determinant, you know how we go through and we do the main diagonal product minus the alternate diagonal product? We're going to do that same thing. We're just going to expand it a little bit. I'm going to go through and I'm going to find the product of the main diagonal, 0, -1, and 1. And then I'm going to find the product of all of the diagonals going that same direction, like 2, 2, 4. So you can see why it was helpful for us to recopy that 4 out here to make it a little easier to see. So I'm going to multiply the 2, 2, and 4. All right, then the other diagonal going that same direction, 1, 3, 0. So I'm going to multiply those guys. So if you'll notice, the 3, 4, and 0 we caught out here, we've caught every number in that matrix. So we took the main diagonal and multiplied and found the product, and we're going to take the diagonals that go in the same direction as that one, multiply those and find their product. I'm going to add those 3 products. Then I'm going to go back and subtract the diagonals that go in the alternate direction. So I'm going to subtract 1 times -1 times 4. I'm going to subtract 0 times 2 times 0. I'm going to subtract 1 times 3 times 2. So then I can just go and find those products. So 0 times -1 times 1 is 0. 2 times 2 times 4 is 16. 1 times 3 times 0 is 0. 4 times -1 times 1 is -4, so it's going to be minus a -4. Minus 0, because this had a 0 in it. Minus 1 times 3 times 2 is 6. So if I combine those, I get the exact same 14 that I got a second ago. So you can do minors and cofactors or diagonals for a 3 by 3. As we already mentioned, if you get something larger than a 3 by 3, like you have a 4 by 4, 5 by 5, something like that, you cannot evaluate that by diagonals. You would have to go back to minors and cofactors. That's the only method that's going to work. The only downside to that is that, like, if you're evaluating a 4 by 4, what's the minor of a 4 by 4? A 3 by 3, yeah. So we'd be talking about doing 4 3 by 3s, right? That's a crazy amount of work. So if I give you a 4 by 4 and ask you to find the determinant, look carefully, because I'm always going to give you a row or a column that has at least 1 0, maybe even 2 or 3 zeros. Okay? So like for this example, I would still want to go with that first column because that's the only one that has 2 zeros. So I could go through and say, okay, I want to find 2 times its minor. If I eliminate the row and the column, then what I have left is that minor. Then 0 times its minor. There's no need to even write the minor of 0 because that answer is going to be 0. 0 times its minor. No need to even write that one because the answer is going to be 0. And then -1 times its minor. If I eliminate the column, eliminate the row, those 9 numbers that are left are its minor. According to the checkerboard matrix, if I start here, it goes plus, minus, plus, minus. So I would go plus, minus, plus, minus in terms of whether I would add or subtract. And so then I would be back to that same thing we saw just a second ago. If I'm trying to find the determinant of a 3 by 3, you could do it by diagonals or you could do it by minors, cofactors, whichever way you wanted to go. So watch for shortcuts on something larger than a 3 by 3. Watch for rows or columns that have multiple zeros. Another shortcut that sometimes they will give us is a triangular matrix. A triangular matrix is one that only has numbers in a particular triangle of the matrix, and all of the rest of the numbers are zeros. They get their name by where the numbers are, not the zeros, but where the numbers are. So like this is a lower triangular matrix because all the numbers are in the lower triangle. This is an upper triangular matrix because all of the numbers are in the upper triangle. This is a diagonal matrix because all of the numbers are in the diagonal. So those are three different types of triangular matrices. Here's the cool thing about a triangular matrix. You can find its determinant by just finding the product of the main diagonal. So it doesn't matter if it's upper, lower, or diagonal. You can find the determinant by just multiplying the numbers that are in the main diagonal. So every single one of these would have the same determinant. It would be negative 12. So if by chance you have something that's like a 4 by 4 or a 5 by 5 or something crazy like that, and they ask you to find the determinant, look for that first, because you don't want to get part way into it and then realize, you're like halfway in doing something like this and then realize that, you had a lower triangular matrix that you could have just done the main diagonal product. Okay? All right, so here is our homework for tonight on pages 596 to 597. Some of these problems, they'll specify for you, do this by row number 2 or column number 1 or something like that. So I'm specifying for you that for number 9, do that one by diagonals so that you try it both ways so that you get a feel for which method you like better when you have to evaluate a 3 by 3 and you're not specified which way to do it, that you have a choice. We are doing all these by hand. There is a way to do determinants on the calculator. A lot of you already know how to do that. We'll work on that after you've proven that you can do it by hand. So if you want to check it on the calculator, you can, but we are still doing these by hand.